Hey kiddos, hope you're doing well. What I'd like to do in this video is to show you why the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I want to also show you a quick little shortcut to get the x value of the vertex for a parabola. So here we go. What I'm going to do is I'm first going to start with standard form of a quadratic. So you have your ax squared plus bx plus c equals some y. And I'm going to find the zeros, right? To do so, I'm going to complete the square. Right? So in order to complete the square, I want to get rid of that c first. So I'm going to go through the completing the square process. So I have ax squared on the left. That's not going to change. Plus bx. And I'm going to subtract c from both sides. Right? I'm going to clear that constant. Now I'm going to clear the leading coefficient, the quadratic coefficient. So I'm going to divide everything by a. Right? I'm going through the same complete the square process as you would with numbers, but this time it's with variables. So on the right I get negative c over a as well. Right? Just divide everything by a. Okay. Now I'm ready to complete the square, and in order to complete the square, if you recall, I take half of the linear coefficient, square it, and add it to both sides. So to the right, I'm going to add half of b over a, which is b over 2a, squared. Right? So half of b over 2a squared is, well, you get b squared on top, and on the bottom you get 2a, the quantity squared, which is 4a squared. Bam. But what I add to the left, I also have to add to the right. So I'm just going to copy and paste that on the right. Boom. And when I just put it first, I'm running out of room. Oh. Okay. Now what I can do is I can rewrite with the left-hand side. Now I'll try to simplify the right-hand side at the same time. So by completing the square, by adding b squared over 4a squared to both sides, I can now express the left-hand side as a binomial squared. And the way that's going to look is x plus the quantity b over 2a. b over 2a squared. Well, so I just rewrote the left-hand side. I completed the square so I could rewrite that as such. And then what I'm going to do on the left-hand side is I'm going to simplify. Right? My common denominator will be 4a squared. So I'm just going to take those two terms right here, and I'm going to combine them with a common denominator of 4a squared. So b squared is already over 4a squared. I don't have to do anything to that. Minus, and then the c is, in order to get c over a into something over 4a squared, I multiply by 4a over 4a. 4a over 4a. So 4a times c is 4ac. Okay, there's your discriminant, actually. Up the top, not the bottom. Bam. Oop. Bam. Oop. There we go. Okay, now if I were to solve for x in the numerical case, I take the square root of both sides, right? And so by taking the square root of both sides, what I end up with on the left is just x plus b over 2a. Right, I kind of undo the squaring by square rooting. They're inverses. And remember, when you take the square root on the right-hand side, you need a plus or minus the square root of all this stuff. Okay. Now here's how I'm going to write that. I look at the denominator, and the square root of that is nice. It's 2a, right? So I split up the square root of all this stuff as really the square root of the upstairs over the square root of the downstairs. Right? So the square root of the downstairs is just 2a. That works out well. Okay, so I'm just going to write the bottom as 2a. The denominator is 2a. Now on top, I got a little bit of a mess, and I can't kind of split that up neatly, so I'll just call it the square root of what I see, b squared minus 4ac. Right? And so now I'm ready just to subtract that b over 2a term from both sides. And when I subtract b over 2a, this already has a denominator of b over 2a from both sides. I can just put that negative b right out in front here. Actually, I'll write it out because this is, so I have negative b over 2a out front. And I'm going to subtract it from here too, so bye-bye. And now since they're all in the common denominator 2a, I can just call it, I'm going to smush them. Alright, so I get negative b, whoops, negative b, put the plus or minus here, and I've added them together. There we go. There's our quadratic formula. Okay? And that's why the quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. The next thing I want to show you is the shortcut to get the vertex, or at least the x value of the vertex for a parabola in standard form. Okay? And I won't go through this all again, but what I will do is I'll take you through up to this step here, right? And notice that little x plus the quantity, the quantity x plus b over 2a squared, right? Now, by the graph translation theorem, that is going to be your horizontal shift, right? b over 2a, right? Instead of x, I have the quantity x plus b over 2a squared. So there's your little x value of the vertex right there, right? So this, if it were x plus the quantity b over 2a squared, then your vertex will be, at least the x value will be negative b over 2a, okay? So essentially, because of this step right here, right, if this were a function y, some of this stuff would change on the right, but what won't change on the left is that piece here. Right? And we have been thinking about the graph translation theorem, and replacing an x with an x plus b over 2a results in a shift left or right, in this case left because it's x plus. And our original vertex for y equals x squared 0, 0 gets shifted in this case to the left, b over 2a. So therefore the x value of our new vertex is negative b over 2a. Okay? To get the y value, all you have to do is plug this x value in for any one of these guys, both of them actually, and that will give you the corresponding y value of the vertex. Now remember, the y value of the vertex is what we're looking for usually, because that's the minimum or maximum value. It opens up or down depending. All right, I gotta go because I'm running out of gas, and Austin is here. Have a great day. Hope you enjoy this video.